Hey
Hey
there, Michelle. You're,
Stephen.
you're you're back. Where have you been?
I'm back from a much needed holiday, but happy to be back here with you. Uh,
Excellent. So, what'd you do? Any highlights you want to share with us?
so we went to the mountains. We went to the Canadian Rockies, and I have to say, you often talk about how we just need to get outside more and connect to nature. There's nothing like spending a week in awe of nature and I disconnected like I wouldn't have been able to any other way. It was phenomenal. Obviously, we were lucky enough to be in such a beautiful setting as the Rockies, but it was great. We saw all sorts of animals. We saw bears and elk and birds and beautiful lakes, and it was fantastic. Yeah,
That's wonderful to
great.
hear. Great. Yes. Reminder to everybody, as soon as you're done watching, attending this wonderful broadcast, close down your computers, go outside, take a walk in the woods, go hug a tree, something, connect to your planet, and you'll be better off, and your planet will be better off too. Okay, well, we're back to the world of PL SQL and SQL. Thanks for joining us. Some grim happenings out there in the world, so we can take a
Mm.
break from all that for a moment, put it aside, and just enjoy our wonderful cyber world in which everything is ones and zeros and not a lot of ambiguity. And yeah, okay. So last week we talked about table functions, which are a really cool feature of PL SQL and other relational databases in which you can build a function that returns a collection, which is kind of like a table, rows and columns. And then you can select from it as if it were a relational table. And I talked a bit about the advantages of it, for example. And in fact, here, why don't you go ahead and share my screen?
Sure.
Let's get right along into reminding folks of what it is that I'm talking about. So, because I want to build on it. So here's, for example, a schema level type. It's a nested table of strings. And I can create that. And here's a function. And the function simply populates the collection with 3 names of species that have big brains, and then returns that list. And then I can query from it as if it were a table. There's the data. Isn't that cool? Now, what I want to talk about this week are some of the drawbacks of table functions as you've seen them so far, and a new type of table function that addresses those drawbacks called pipeline table functions. So I mentioned this last week, the 2 big drawbacks for table functions that I'm aware of, and if you have others, please let us know in the comments. Twofold. One, well, let's take a look. I declare a collection. I fill it up with data. Okay, right there, you should stop. All of us should stop, because whenever we're working with a collection and we're filling it up with data, the question becomes how much data? Because that collection takes up PGA memory, process global area memory, session specific, and it's not unlimited. And you can blow out the memory in your session. So whenever you're working with collections, you have to be aware of the possible downside of PGA memory consumption. And obviously in real table functions, you're not just throwing in a few rows like that. You might be querying data from multiple tables, building a programmatically constructed data set, and then putting it into a collection. It could be thousands of rows. You could have a serious issue around memory consumption. The second problem with this is that in general, as you I'm sure are aware, PL SQL is not a multi-threaded language. So when you call a function, everything stops and waits around until the function returns its value, which generally speaking is not an issue per se in PL SQL because it all works that way. But suppose I'm running a really big query and I'm fetching from multiple data sets, including a table function, and I'm using parallel query. There's a great feature that allows the engine to break up large data sets and then have multiple queries running simultaneously and then merge the results back together. Cool, parallel query. But the function serializes that parallelization. So 2 issues with normal table functions. One, possibly too much PGA memory consumption. And second, the serialization of execution inside a parallel query in similar situations. So what I want to talk about to you today is a really cool enhancement on top of regular table functions called pipelined table functions. We're going to start with a really, really simple example, take a look at some more slightly complex examples, and then talk about some performance-related issues or questions, and of course, come up with questions as you have them. And I'm sure if I have my usual characters on this call, you'll all have a lot of experience with pipeline table functions, so jump in and provide additional information that I forgot to. Okay, so what I'm going to do is convert this function, a normal table function, to a pipelined table function. Now notice, by the way, that there's nothing in this definition that says it's a table function. In fact, I can call this same function inside a PL/SQL block. No problems. All right, so now let's go on to a rewrite of this ridiculously silly little simple table function. Here it is as a pipeline table function. So first of all, notice you got to tell Oracle it's a pipeline table function. Second of all, the cool thing about it, and it's built into the name, is that you're not building a data set like a collection and then returning the collection. What you're doing instead is piping a row of information back out of the function as you've completed the construction of that row of information. So you can see here now that instead of declaring a local collection and populating it and returning the list, what I'm going to do is pipe row and specify what I want to send back. Pipe row, pipe row, pipe row, pipe row, pipe row, usually within a loop of some sort. And then when I'm done, and this is a really interesting aspect of a pipeline table function, I return nothing but control. I'm not returning a data structure, which is what you almost always see in a PL/SQL function. I'm simply saying I'm done, go back. The only place you'll see return semicolon when not inside a pipeline table function is, and you probably have never done it yourself, is in a procedure. Because in a procedure, if you want to, you could just say at any point in your code, return, and it gets you right back. It's very unstructured. It's kind of like super major go-to. Instead of go to the end of the procedure and then you're done, just return wherever you are. Generally not, I would not recommend it, but that's what's going on here. So pipe row, return value. Let's compile this function. No problem. And then let's query it. And there's my data, just like before. But here's one interesting aspect of pipeline table functions. Can I call it inside PL/SQL? And the answer is no. This kind of table function, it just says table functions, but this table function is not allowed in PL/SQL scope. So one of the trade-offs for pipelining, when I move away from having that locally declared collection, returning that collection, is that you cannot call it in SQL and PL/SQL. Pipeline table functions are only for use inside a SQL statement. It could be a SQL statement inside PL/SQL, which I'll show you in just a moment, but it has to be called from within SQL. So that's one of the differentiators. If you have a table function that you use inside your PL/SQL code natively, but you also use in a query, you cannot use pipelining. Now let's talk about why this addresses the two drawbacks that I saw before, that I outlined before. One problem was memory consumption. So notice, I don't declare a collection. I just tell it what type of row is going back. It's kind of like a return in a cursor definition. And then I pipe that information back. So there's no local variable. There's no PGA consumption. You're just sending it back to the calling query as needed. And then the question is, what about the parallel serialization? So the answer is that when you're working with pipeline table functions, it can be executed in parallel. You can parallel enable the function. I don't have an example of the syntax to show you, partly because I've never done it myself. So I would just show you some syntax and not really be in a position to demonstrate it or talk about it in detail. But if you are working with parallel query and you do have table functions, definitely check out pipeline table functions and the parallel enable clause, and you can tell it how to parallel enable the data coming in. So that's the key aspects of a pipeline table function. All right, so first of all, do we have any questions? It looks like we have no comments yet. Is that right?
No comments yet. Quiet group today.
Okay. So we'll just keep on cruising along. So you might say, well, Stephen, you tell me that we don't see a difference in memory consumption, but is that really true? So let's take a look at a more complex example and some code I ran to actually check to see, yep, results are still there, good. Check to see if it actually did improve things. So here's a more typical complex scenario. I've got data in one table. It's called the stocks table. Every ticker has a trade date and the open price on that date and the close date on that price. And I need to do a transformation on that data. So essentially this is data warehouse operations, ETL. And I need to transform that data into the ticker table, in which essentially it's a 1 to 2 branching. Every ticker on this day has an open price and a close price. You don't need a pipeline table function to do this. You can do it in SQL, but assume it's more complex. So A couple of things. First of all, what I've shown you so far is a very simple example of a pipeline table function returning a single scalar value. Mostly you're going to be working with pipeline table functions that return a complex structure, multiple columns of information. This can be done either through a schema level object type or a package-based collection of records. Here's an example of using the object type. So I create an object type that looks like the ticker table. I create a nested table on top of those object types. I've got a package here. This is going to be used in my streaming table function I'm about to show you. Here's my doubling function, but not pipelined. So I declare my collection, my internal collection. Sorry, I declare my internal collection to return. I've also got a local collection that I'm going to fill up. And what's going on here, in fact, I'll show you the call first. This will give you a much better sense of the kind of complex scenarios you can work with table functions and pipeline table functions. This is what I wanted to show you. So in this kind of situation where I'm pivoting and transforming data, what you're going to be looking at is a streaming process. So this is the same code you just saw before, my doubled PL and doubled no PL. And then I'll show you the pipeline version. But here's the idea behind these kinds of functions. I'm passing in a cursor. See that? So I've declared a ref cursor, a cursor variable. I'm passing in a cursor variable here. I'm fetching from that cursor variable, and then I'm doing my doubling for each row in that cursor, in the collection based on that cursor variable. So I get all the rows, the first 100 rows of my collection. I double them up, putting them in the collection, and then return them. So that's my classic table function. Here's the reason you build things like this. Right inside a single statement, I need to take all the data from stock table and move it into my ticker table, the doubling process. I'm going to pass a data set directly to the pivoting or doubling function as a parameter, right? That cursor variable parameter. The way I do that is I write the select statement of the data I need, in this case, everything from the stock table. I put it inside the cursor expression. That converts it into a cursor variable that I pass to PL/SQL, which is pretty cool all by itself. Literally, I'm passing a select statement to a PL/SQL function. It then does that, iterating through the data set that's been passed in, fills up the collection, returns it. And then I can do all of that inside a single SQL statement. You can even have multiple transformations in stream. It's called a streaming table function. Okay, so that's what I did here. I basically took a version of that code. So here's the doubling in a collection and returning it. Here's that same pipeline version. So again, I'm still getting that cursor variable coming in. I get 100 rows at a time with bulk collect. I do those pipings right here. So here's my pipe row now. Instead of having a single scalar value, what am I going to pipe back? I'm piping back an object type instance. So I use my constructor function on that type. I pass in the values mostly from the table that I passed in, the select statement that was passed in. But I also add my open and close. Those are the new values for the doubling process. And notice I just pipe and pipe and pipe and pipe and pipe, and then I return. Okay, so then then the question is, what kind of performance differences can I see between pipeline and non-pipeline, and what about memory consumption? Now, like I said, I don't have a parallel query operation to set up a really complex scenario to show you the impact on performance, but here I found a way to do it. I've got a little utils package here that basically shows me timings and PGA consumption. All of this code is available on LiveSQL. You see links to it on my blog post that goes with this session today. But I've got a function that gets me the amount of PGA consumed, and I use dbmess get time or get CPU time to calculate times. So that's just all my utility stuff. Okay, here we go. So what I'm going to do is that same streaming process. So take the stocks table, pass it to my doubling function, double it up, pass it along as a table, select from it, insert into tickers. But what I'm going to say is, you know what? I only want 9 rows. Okay. And I do the same thing for my non-pipeline version. I only want 9 rows. Let's see what happens as a result of that. Okay, here we go. So this is the result of that run. For the pipeline version, it took 16 centiseconds, hundredths of seconds. It took 327,000 bytes of memory, 16. And look at this, not pipelined. It took 554, 5.5 seconds compared to 0.16 seconds. And it took a lot more memory.
Wow.
So you can see, right? Isn't that really something? The benefits are really clear. Their PGA consumption is kept to an absolute minimum because you're simply not constructing anything of size in that function. And what you see here is the demonstration of how this piping really works. Essentially, as this query is executing here, this pipeline version, it's sending a row back each time. And as soon as it gets the 9th row back, the SQL engine says, wait a minute, you only wanted 9. I'm done. And it literally stops because it's an asynchronous passing back of data compared to function completion. With the non-pipeline version, it says, okay, I'm going to do some work for you. And it takes my 10,000 rows and it doubles them to 20,000 rows and it builds a big collection and it passes it back. And the query says, oh, great, thanks so much. But I only wanted the first 9 rows. But you had to pay the price, right? You had to sit there and wait because it's a standard function. So there you see that the value of that pipelining right there in both ways.
So that's great. Stephen, there have been a few comments that have been coming in as you went in.
Great.
I think the timing actually was great. You want me to stop sharing? So just as you went into this last example of the performance differences, Rachel had asked if you could give an example of a situation. So that was great timing. You had great foresight, Rachel. Hopefully, Stephen.
Sorry.
Yeah.
No. And one other thing about that. So what I talked about is the use case is this idea of having a parallel query operation. Where it'll allow you the table function can participate in the parallelization and not serialize. The other use case is on a website. Now, I can't say I've done this for myself, but I've talked to others who have. So you can have let's say a front end you built in JavaScript or Java, whatever the case may be, and somebody enters some criteria and presses, go, and then it goes out and executes the code and it brings back thousands and thousands of rows, and you sit there waiting and waiting as the vertical scroll bar gets smaller and smaller and smaller on your page, and people hate to wait. So those queries can be driven by pipeline table functions, and the calling environment can actually grab that data and display it while the function is still executing and bringing back the data. So pipeline table functions can also be good for reducing the amount of time it takes for the user to start interacting with their data, even if it's actually not finished yet. Okay. Let's keep going.
Burgess had a question here.
So Burgess, this is exactly the main point of pipeline table functions. It returns it row by row. So you don't batch it. So it's either row by row or it's a total batch. So the total batching process is all or nothing. That's the normal table function. It's not like a bulk collect where you can say, get me one at a time or get me all of them, or wait a minute, just get me 100 at a time and pass them back. There's no need for that because that kind of limiting process, bulk collect limit 100 is all about reducing PGA consumption in your session. And the main point about the piping with pipelining is that there's no PGA consumption. So I'm not sure if you were asking about some sort of middle ground between one at a time and all, but there's no middle ground because it just doesn't apply in this case. And I see that Burgess also made a comment about it's mostly useful. Yeah, so definitely you probably see the pipelining most used in the context of the parallel queries and streaming table functions in data warehouse. Yep. Exactly. That's exactly right, Mark. You can basically get to work on that data right away and you don't have to sit there and wait. Mm-hmm.
And you did, of course, is mentioning chapter of your book.
Yeah. No, this is not me. Wait a minute. Did I write a book called Oracle PL/SQL for DBAs?
Did you write anything with Stephen and Arup?
Oh yeah, I did that with Arup. Yeah. Well, I often say that I've written 10 books on PL/SQL and I wrote 7 too many. Arup did almost all the work on that.
And that's why you don't remember it very well, obviously.
Arup, if you're on this call, please don't be offended. Yeah, so there's some great stuff on parallelized table functions there, and also I'll show you some links to others today. Great stuff online. I even found a blog post from Tom Kyte that I want to share with you guys about pipeline table functions. All right, is that it?
So Rachel is asking about the tie-in to Apex, and I have to say, as an Apex developer, was not very familiar with pipeline functions. I've never used them or had to use them, other than when I mentioned this gentleman I worked with to you yesterday. So, do you have any thoughts about tie-ins with Apex?
Yes. So as far as I know, there's nothing in Apex itself that allows you to take advantage of pipeline table functions unless you were executing a parallel query inside a report, which is highly unlikely. So I don't think that, as I mentioned before, like you might have a Java program that can read the rows from the pipelining and use them sooner. I don't believe it works that way in Apex. So I don't think that you can see the advantage of the rows coming back and seeing them sooner on the screen. Please, if anybody knows out there, let me know. And I probably should have checked with my Apex presidents on beforehand. But certainly, there's still an advantage of using pipeline table functions in Apex from the standpoint of your PGA memory consumption going down. So if you're building a report on top of a table function, which is a pretty common scenario inside Apex, and it's in part a way to hide all the complexity of your SQL or your data construction behind a function, and then your report is literally select star from function call. So there's certainly lots of benefits there. And did I just lose my train of thought? Right, but there's always the benefit of the reduced PGA consumption. Now, so I think one question that often comes up is, why would I ever use a normal table function? Why wouldn't I always use a pipeline table function? And why don't you put up Burgess's comment, because this is another good point. I mentioned it last week as one of the use cases for table functions, but certainly good to remind. So essentially, you can treat a table function as if it were a parameterized view. So you can select from the function, pass in parameters. You can't parameterize views right now.
Right.
But this points out a really good point here. For a lot of developers, from my experience, people talk about pipelined table functions when they really mean table functions. So there's this conflation in a lot of developers' heads of it's a pipeline table function, or they always go to pipeline table functions first. Now, that would be fine, except for two possibilities. One is you can't use it in your PL SQL code, only in SQL, which is probably not a big deal. And second of all, you might ask yourself, well, wait a minute, is there a performance penalty to be paid? Is it, in other words, if I make everything pipelined, even if I don't use the actual piping back, I don't take advantage of the asynchronicity of the data going back, is there a price to be paid for that? Let's take a look. So if you could share my screen, because I did write some code to check this out. So what you've seen so far is that it really works. What this really says is piping is different from synchronous return of data, and it clearly uses a lot less memory. So then what I did was take a variation on that code to ask, well, is there a performance impact on making it pipeline compared to non-pipeline? So here's my doubled pipeline, here's my doubled non-pipeline. And what I did was put it inside a loop. So I'm going to execute this query. Whoops. I'm going to execute this query multiple times. In this case, 10,000 times. So we'll see what the impact is of calling this thing over and over again compared to calling this thing. And the answer is non-pipelining is slower. So here's the pipeline version. Again, much less memory, and it's also faster. So you're not paying a penalty for doing that piping back. In fact, I would assume that anybody looking at my question would have said, well, it doesn't seem like that would be faster, right? You're not constructing something internally, then returning this big data set. So the answer is yes. There's no price to be paid for going to pipelining. I don't think there's anything wrong with setting as your standard that you always make it pipelined. The only downside I can really see is that it just is weird looking. So instead of populating your collection, you've got this piping process. Whoop, I don't know, where's my piping? Anyway, it's in here somewhere. Mm-hmm. So the code that you write, if you're not used to it, and it just froze, is fairly unusual. Let's see, now what I'm going to do while my session is resetting, I'm going to go over to LiveSQL. We'll talk about one more topic, see if there are more questions.
Yeah, I'll just throw up Niels's comment about exception, not to use a when others exception handler in pipeline table function.
Thanks, Niels. I'm about to go into no data needed. Appreciate it.
All right. Okay.
So again, go to LiveSQL, look for pipelines. You'll find lots of examples. This is part of my tutorial on table functions. There are various different examples that folks have put up here. And take a look and go exploring. Now, so Niels just talked about, let's talk about exception handling with pipeline table functions. So here's the question. What happens if you've got this function that returns a bunch of data? This is a bad example. But for some reason, right in the middle, we did a return. In other words, we didn't get to all the data. Or in fact, this is an example of it right here. What I'm saying here is I'm going to shortcut what this function is doing. So it's going to return 20,000 rows, but I only want 9. So what's the downside of that? What can possibly go wrong? Well, hello, Tom. How you doing, Tom? So Tom Kyte, hopefully you all know who Tom is, but some of you who might be new to Oracle Database might not know Tom was probably the most knowledgeable person about Oracle Database in the world, and also a really fantastic communicator. He retired in 2016. And he wrote a blog. Anyway, you can pretty much find out all sorts of stuff from his old blog, no matter how old it is. So this is from 2010. And here's there's another exception in Oracle called no data needed, which is different from no data found. And here's the basic idea that he lays out really nicely in this piece of code, in this blog post, is that very often in our programs, we have an initialization process, we do our code, and then we do a cleanup. There's some sort of cleanup that occurs. Now, and you can implement that in any number of ways, but here's an example of that. So I do my initialization, I do my piping, I do my cleanup. And if you're running all the way through the data set, good. All the steps have been performed. But suppose we short-circuited that pipeline table function. Then what you'll see is that cleanup step never happens, because when this second row, when the first row in this case was piped out, the SQL engine said, good, I'm done. I'm not going to go back to the function and get any more data. So this stuff never executes. So the bottom line is when you have a pipeline table function that has some important cleanup operation in it, then what you need to do is take care and pay attention to the no data needed exception. So the no data needed exception will be raised by the engine if you short circuit, if the function is terminated before all the data has been returned. And the interesting thing about this exception is that it is ignored unless you specifically handle it. So notice there's no error, right? It just came back. But actually the no data found exception no data needed exception was raised. So the bottom line is that if you have cleanup that you need to perform, then you should check for it explicitly and then do your cleanup operations. And if you have a when others clause, now let's jump over to Oracle Base. So good old Tim Holland, a fantastic Oracle Base website. He should win awards for this website if he hasn't. He's got a great example of pipeline table functions and no data needed. And the point he makes here is that if you're going to have a when others in your pipeline table function, you need to break out when data needed separately, because it really should be treated differently from the when others, or at least if it is going to be treated differently, you need to treat it differently by breaking it out. So that's what Nils was referring to in terms of the no data needed. And thank you, Tom, for coming through as you have for us for so many years.
So Stephen, you've referenced Tom's blog, Tim's blog, some scripts on LiveSQL. Are those all? You want me to? Yeah. Are those all linked, referenced in your blog post? If
That's right. So the blog post will have,
and we'll put them in the description. Okay.
Yep, they're all there. No problem there. So that I think pretty well covers it. So use pipelining to reduce your memory consumption. If you have any kind of parallel query operation, or your front-end developers are looking for ways to speed up the release of at least the initial state of data to users, then it's another reason to use pipeline table functions. And there doesn't seem to be any real downside to always making your functions pipelined, as long as you know you're never going to want to call them in your PL SQL code directly. Okay, now before I move on to any other questions and comments that come up in my book of the week and the organizations and all of that sort of thing, just wanted to give all of you a really special heads up. This is not the end of my table functions series. Next week, I'm going to do a third topic on table functions. We'll look at 2 different, more specialized kinds of table functions. And I've got a special guest coming on, Chris Saxon of current Ask Tom fame. So he and Connor McDonald now run the Ask Tom website. Chris is going to join me to share his work that he's done on these types of interesting table functions. So spread the word. Be sure to come back next week for that one.
That's awesome. You have friends in high places, Stephen.
Yes. Well, he used to work for me. Should at least come when I call. And here's another comment from Judith. No data is the only exception that is raised inside a PL SQL unit, but not by any action performed by the PL SQL unit itself. You're probably right, Judith. It's a very unusual kind of exception. And probably, though I can't speak to this for sure, probably they built pipeline table functions. And then somebody said, wait a minute, we've got this weird situation that might happen. We need to find a way of communicating that back out, but to not make a fuss about it. In a way, it's kind of like no data found, in that if you're calling a function from within SQL and the function raises a no data found exception unhandled, then the SQL engine says, nah, who cares? I'll just treat that as a null. So those are two different ways that exceptions raised from PL SQL code are treated unusually in the SQL engine.
Rachel's excited about Chris. Yay.
Yeah, Chris is awesome. You're right. Absolutely. Yeah.
Burgess has a last question.
So in terms of performance, have you run a test to compare their performance as compared to regular table functions in situations when you have to join the output with another table? So Burgess, I haven't. And that's an interesting point. So I think the point that Burgess is raising here is that if you're doing a join with another table, pipelining back is not going to do you a lot of good because you're joining the whole data set to another table. So in that sense, the parallelization feature will not really be buying you anything, but you're still getting a benefit out of the reduced cost on memory. And Burgess, I would say from the one test I did run just before, you really shouldn't expect to see any difference, where it might still be a little bit faster than a regular table function. You're just not really gaining anything by the asynchronicity of the data transfer. And a comment from Sean. Sean, thanks for joining us today. Sean is an amazing SQL technologist in Oracle DBA. I have a collection generated in a package table function. Would it still be faster to use a pipeline function to pipe the elements back instead of just returning the entire collection? So in this case, Sean is saying, look, I've built up a collection. Maybe somebody else built up the collection, passed it into me. So why not just return it? Do I need to go through the trouble of doing the piping? And I think that since you've already got the list in place, you're not saving on memory. And certainly if you can avoid executing the table function multiple times, that's a good call. And I would think that there might still be a benefit because you're not passing back a big chunk of data at once. So that's probably got more to do with network implications than the database itself. That would be my guess. But I would say the point you're raising about avoiding multiple calls is probably a good deciding factor there. And Judith, the problem is that you should probably use some form of the extensible optimizer for getting correct statistic for table functions. Yes. And you know what? I'll make a note to myself. This is something I'm going to ask Chris to also talk about, which is that when you've got a table function called with joins with other tables and so on, of course, the optimizer can't look inside your function and figure out what to do about it. It's a SQL optimizer, and the PL SQL optimizer doesn't matter for this. So there are things you can do to tell the optimizer through hints how you should treat that function. But that's not my bailiwick. And I'll ask Chris to comment on that as well. Thank you, Judith. All right, wow. Okay, well, this went on for quite a while. So what I'm going to do is move on to the
33 minutes, Stephen. No pressure.
Yeah. I'm going to move on to the non-PL SQL side of things. Are we going to lose this session? It'll keep going.
No, it'll keep going. But
Okay.
if people have just scheduled 30 minutes, they're probably,
So Michelle, would you like to pick a person to pick the organization?
Oh,
Can I have a nomination? I'd like to have Burgess do it since
awesome. Okay.
Burgess contributed a lot. So the way this works is that every week I show 3 different organizations that are working to heal the planet at a time in which our planet needs enormous amounts of healing. And Burgess, if you could pick which of the groups that InSum would give $25 to, that would be great. And then I'll share.
You are about to share.
I'm about to show you guys, right? So go ahead and share my screen. So 3 different groups. One is the Bonobo Conservation Initiative. I think I did talk about bonobos last week, but it's always good to talk about them some more. Bonobos are, as they put it, humankind's sister species. So there are 2 species that we've identified as being close to us genetically, essentially, on the tree of evolution: chimpanzees and bonobos. Chimpanzees are much better known. Bonobos live only in Madagascar. Only 15,000 or so left in the wild. They're under serious threat of extinction, and they're amazing creatures. Very different from chimps, very different from humans. They have matriarchal societies. They're much less combative and aggressive. And as far as I can tell, they just have sex with everybody all the time. Interesting species. So bonobos, save the bonobos. Save the orangutans. So orangutans are other primates, and they're in serious trouble. And the problem is so awful in a way. So one of the biggest problems for orangutans, this is in Indonesia, is that in the United States and Europe, we did a big switch to biofuels. So there was an encouragement to use biofuels to cut down on the amount of fossil fuels. And what that did was unleash all sorts of unintended consequences. So now we have this massive amount of corn being grown unsustainably, using a lot of water just to make biofuels, but also entire forests in Indonesia are being wiped out so they can put in plantations of palm trees to generate palm oil to use in biofuels. Really awful. So we'd really like to not have them go extinct. Finally, there's a lot of talk about planting trees and how, if you use your credit card, we'll plant a tree for you. Do this, do that, we'll plant a tree for you. That's maybe nice. I think most of those initiatives are enormous failures and distractions. What we really need to do more than anything else is keep the trees we've got, especially the old growth large forests. So there's a group called the Old Growth Forest Network in the United States that works on that around the United States and around the world. And I love that group. So Burgess, let us know which of those 3 organizations you think we should contribute to. Well, I move on to my favorite book for this week, and it's called The Oldest Living Things in the World. Yeah, that's right. Go down a little bit. Go down. You're too big. So this is a book I actually have. It is another one of those, I guess you'd call it a coffee table book. It's big and heavy, pretty expensive. It costs $60. So I'm not expecting a lot of you to buy it, but I am expecting a lot of you to go check it out online and just appreciate the planet we've got. So I'm looking at one page, Palmer's Oak. It's called Scrub Oak. It's 13,000 years old. And it just goes on and on of all these amazing living things that have been around for such a long time. And now they're pretty much all under threat because we want Lunchables. We want things in plastic. We want things to be super convenient. So we got to stop that. But that's a book I encourage you to check out, and a planet I encourage you to check out. And if you could stop streaming, stop sharing. Thank you. Did Burgess reply? Burgess, pick an organization. Do you want to save orangutans? Thank you. It's hard to choose. Okay, the Old Growth Forest Network. Right. I like that a lot.
Too.
So just a couple of closing comments for those of you who are still here. One of the things I think we who are in the middle class or higher, in other words, we live lives of relative comfort and excess in a lot of ways, is look at striking out as much of that excess as you can. And what I think it's going to come down to, start getting comfortable with being uncomfortable. Mm-hmm. So one of the big problems we have in this world is we don't want to have any problems. Us humans should have placid, wonderful lives all the time. Obviously, not true for billions of us, but I'm saying among those of us who live in privileged circumstances, we have to start getting used to not having all those comforts because they are going to go, they must go away if we have any chance and not overheating our planet to just massive widespread destruction. So do your bit now. Look for ways to cut down on things that you could buy, you could do that would really make you kind of comfortable, but have a big price to pay. Lower the temperature on the air conditioner, raise the temperature on the heater, et cetera, et cetera, et cetera. Just do everything you can. And of course, protest government's not doing enough. But if we all do something, we can have an enormous impact. All righty. That's it for this week. Good to have you back, Michelle. Thanks to seeing all of you and your great comments today.
Thanks for your participation. It's been great.
Yep. So stay safe. Please get masked, get vaccinated. Don't be like so many people in the United States who are destroying our country today. Thank you. Take care. See you next week.
Thanks, everyone. See you next week. Bye.